Welcome to the cosmic theater where a captivating and often violent drama unfolds, galactic cannibalism. In the vast and mysterious expanse of the universe, larger galaxies engage in a spectacular process, the devouring of their smaller neighbors. But what exactly is galactic cannibalism, and how does it shape the very fabric of our universe? Imagine the universe as a grand tapestry, woven from the threads of countless galaxies, each vying for dominance in an eternal dance. Today, we will embark on an exhilarating journey through this celestial phenomenon, exploring the mechanics of cosmic consumption, the awe-inspiring interactions between galaxies, and the profound implications for the future of our universe. So, prepare to delve deep into the heart of our cosmos, where the giants roam and the laws of gravity dictate the fate of galaxies. Galactic cannibalism refers to the process in which a larger galaxy gravitationally attracts and ultimately consumes a smaller galaxy. This cosmic feast is not a swift occurrence. Rather, it unfolds over immense stretches of time, millions, sometimes billions of years, driven by the powerful gravitational forces at play in the universe. Picture two galaxies in the vast cosmos. One, a towering giant with swirling arms of stars and gas. The other, a diminutive spiral struggling to hold its shape. As they approach, the gravitational pull of the larger galaxy begins to dominate, initiating a mesmerizing transformation. The smaller galaxy doesn't simply vanish. It experiences a series of stunning changes. Tidal forces stretch and distort its structure, creating long, trailing streams of stars and gas, like cosmic ribbons unfurling into the infinite void. These tidal tails, often filled with newly formed stars, are a breathtaking testament to the gravitational ballet unfolding in the depths of space. Eventually, this grand process leads to the complete assimilation of the smaller galaxy, which becomes a part of the larger, enriching it in ways that will echo throughout its cosmic existence. The process of galactic cannibalism unfolds in multiple stages, each one a stunning demonstration of the forces that shape our universe. Initially, galaxies may pass each other closely, like dancers in an elaborate ballet, causing gravitational interactions that distort their shapes and set the stage for deeper engagement. These interactions can lead to dramatic encounters where the larger galaxy begins to draw in stars, gas, and other materials from its smaller counterpart. Imagine the tension in this cosmic dance as the larger galaxy's gravitational field stretches the smaller one, creating spectacular tidal features. As the gravitational embrace tightens, the smaller galaxy becomes more distorted, leading to the formation of magnificent tidal tails, long, luminous streams of stars that trail behind as it succumbs to the gravitational pull. This is not just a mere dissolution. It's a spectacular transformation where new star formation is ignited in the compressed gas regions, resulting in vibrant bursts of stellar activity. The grand finale of this process occurs when the two galaxies merge, their shapes blending together in a breathtaking display of cosmic forces. The smaller galaxy is absorbed, its stars and gas melding into the larger galaxy's structure, creating a new, hybrid entity that carries the legacy of both. This merger is not just a collision. It's a rebirth, reshaping the identity of both galaxies involved. A prime example is our very own Milky Way, currently on a collision course with the Andromeda Galaxy. In about 4.5 billion years, these two giants will merge, transforming their structures and creating a new galactic form that will be a blend of both. Such events remind us that galaxies are not static. They are dynamic entities in a perpetual state of evolution. The evidence of galactic cannibalism is all around us, observable in a multitude of galaxies scattered throughout the universe. Take the antennae galaxies, for instance, a stunning pair of galaxies currently caught in the throes of merging. Their dramatic appearance, characterized by long tidal tails and a vibrant burst of new star formation, serves as a striking example of the powerful forces at work during these cosmic interactions. As we peer deeper into the universe, we encounter the Whirlpool Galaxy. This grand spiral has absorbed several smaller satellite galaxies over its lifetime, enriching its structure and enhancing its star population. The cosmic dance between galaxies is not merely beautiful. It offers critical insights into the processes that govern galaxy evolution. Astronomers study these interacting galaxies to understand the underlying mechanics of galactic cannibalism. Observations reveal not only the remnants of consumed galaxies, but also the vibrant new stars that emerge from the chaos, illuminating the cosmic narrative of birth, death, and rebirth. Additionally, deep sky surveys, such as those conducted by the Hubble Space Telescope, have provided a wealth of data, uncovering countless examples of galactic interactions and mergers, allowing us to piece together the intricate history of the universe's evolution. Galactic cannibalism is not merely a fascinating process. It serves as a crucial driver of galaxy evolution. When galaxies merge, they can trigger intense bursts of star formation, creating new stars from the gas and dust that becomes compressed during the interaction. This phenomenon, known as a starburst, can elevate the rates of star formation to hundreds or even thousands of times greater than normal. As these new stars ignite and shine, they not only illuminate the newly merged galaxy, but also contribute to the intricate interplay of forces within it. Moreover, these mergers significantly alter the distribution of stars and the overall dynamics within galaxies. Central regions may become densely packed with stars, often leading to the formation of supermassive black holes that reside at the hearts of many galaxies. These black holes can grow significantly larger through the accretion of material from the merging galaxies, influencing the evolution of their host galaxies for eons to come. Their immense gravitational pull can also affect star formation patterns, creating an intricate balance that shapes the galaxy's future. In essence, galactic cannibalism acts as a sculptor of the cosmic landscape, molding galaxies into larger, more complex structures. It is a testament to the dynamic nature of our universe, where galaxies continuously interact, merge, and evolve in a grand cosmic ballet. As we gaze into the future, the ongoing processes of galactic cannibalism will continue to unfold across the universe. The Milky Way's impending collision with the Andromeda Galaxy is just one of many examples illustrating that galaxies are not static entities, but dynamic participants in an ongoing cosmic narrative. In approximately 4.5 billion years, our galaxy will merge with Andromeda, resulting in a new galactic structure that will be fundamentally different from either progenitor. This monumental event will not only reshape our cosmic neighborhood, but also pave the way for the formation of new stars and potentially new planetary systems. The aftermath of such mergers can lead to a variety of outcomes, from the birth of a new elliptical galaxy to the creation of an entirely new system of star clusters. These future collisions remind us of the grand scale of cosmic time and the continuous evolution of the universe. Each collision, each merger, serves as a chapter in the story of galaxies, illustrating the intricate connections that bind them together in the vast tapestry of space. In conclusion, Galactic cannibalism is a captivating and complex process that highlights the dynamic nature of our universe. As larger galaxies consume their smaller counterparts, they reshape the cosmic landscape, creating breathtaking structures and fostering the birth of new stars. Thank you for joining us on this exploration of galactic cannibalism. If you found this cosmic journey enlightening, be sure to like, subscribe, and stay tuned for more fascinating insights into the universe we inhabit.